only you stand up. You'll take
No, no, thank
you. Sure, good.
So, good morning everyone. My name is Agata Kmiecik and I'm a Research and Technical Specialist at Central Institute for Labour Protection, a National Research Institute in Poland. And today I would like to present our pilot study on Chatbot as a support tool for accessing information on personal protective equipment. So let's start with the whole idea for our Chatbot. So currently it's in a development stage and it is intended to allow easy access to the information on personal protective equipment. The preliminary version of our Chatbot focuses on protecting against chemicals and infective agents, and as for now it is only available in Polish. Its main target users are manufacturers and users of PPE. And what's important is that both visual design and Chatbot's content was adapted to the target users' needs. And it was possible because they were involved in every part of the development process. Another key feature of our Chatbot is what differentiates it from the widely used tools such as Chatbot. All of its answers are verified by the experts. So we came up with an idea for this Chatbot because we've noticed that it may be time-consuming to find such important information in the internet, and it is also very difficult to verify if the information you get from the first search results are true. Additionally, the information you get from some website can be obsolete and may differ depending on which website you choose. So now I will quickly tell you about how does this Chatbot work. So the backbone of our Chatbot is its database, and it is adapted to the users and manufacturers of PPE. It contains questions and answers about personal protective equipment. The principle of operation of our Chatbot is based on matching users' prompts with predefined questions from our database. And the Chatbot has two operational paths. The main one is just when the user is typing in the question in the text field. And the script path is when the user is choosing certain blocks with categories that interest them. Developing the Chatbot is an interactive process that consists of continuous testing and ongoing improvements. Our Chatbot was subjected to usability testing, and to better present the idea behind this test, I will start with some definitions. So, according to ISO 9241 Part 11 standard, usability is an extent to which a system, product, or service can be used by specified users to achieve specified goals with effectiveness, efficiency, and satisfaction in a specified context of use. Effectiveness, efficiency, and satisfaction are three key metrics to measure usability, and the definition are as follows. Effectiveness is accuracy and completeness with which users achieve specified goals. Efficiency is resources used in relation to the results achieved. And satisfaction is extent to which the user's physical, cognitive, and emotional responses to the results from the use of a system, product, or service meet the user's needs and expectations. Even though the ISO 9241 series of standards doesn't specify how to measure these metrics, there are many ways to do that. Efficiency is usually measured by measuring the time needed to finish certain tasks. Effectiveness is usually measured by calculating the success rate, that shows the percentage of attempts that result in success, and calculating the numbers of errors per task. Satisfaction can be measured by using standardized questionnaires, such as system usability scale or questionnaire for user interaction satisfaction. Usability testing is a very important part of developing any system because it ensures that products are effective, easy to use, and accessible. It is really important in the context of a Chatbot because eliminating the problems identified during this testing can make the Chatbot easier to understand and use, which can reduce user stress and discomfort. And also, the better the Chatbot design, the better overall user experience. So the aim of usability testing of our Chatbot was to ensure the best possible interaction between the user and the system. And the process of testing consisted of defining objectives so that we know which functionalities of our Chatbot we want to test, defining tasks that users should perform involving all of the Chatbot's functionalities, preparing chatbot's prototype, conducting tests, measuring task completion time, clicks, success rate, and SAS score, and of course analyzing the data. So now I'll give you a quick background of what tasks the user have to do. So task 1 was about the script path. It was to find the answer to the question about the performance parameters for type 4 chemical coding. And in this task we were checking if the user knows where is the chatbot's feature on our website and how they work with the chatbot for the first time. Task 2 was also about the script path. It was to find the answer to the question of what type of SIMs are best to use in clothing protecting against liquid chemicals. But this time the user had to start from the point where they previously ended. So we were checking if the user knows how to navigate between certain categories and how to go back to the main category selection. Task 3 was about the main path. It was to find the answer to the question what standards type 3B clothing that must meet. And in this task we were checking if the user knows how and where to type in their question. The score was very similar. It was also about the main path. It was to find the answer to the question of what should be on the label of clothing protecting against infectious agents. But this time the chatbot's prototype was programmed not to give an immediate answer, but to match several similar questions from which the user had to choose the correct one. And in task 5, the user had to choose the path, whatever they wanted, and it was to find the answer to the question of what should be included in the product's user manual. And in this task, we were checking which path is preferred by the users. To conduct this test, we used 4 key tools. The first one was Figma, and we wanted to create a functional chatbot prototype. A Figma prototype was connected to Maze platform that we used to generate the link for the users, conduct tests, and collect the data. From Maze, the users were transferred to Agata platform, on which we collected the responses from the SAS questionnaire, and all of the data gathered was analyzed using Python programming language. So the tests were carried out remotely. A link generated by Maze was sent to selected companies. In the picture you can see a screenshot of the test from the user's perspective. In the white field there is an instruction for completing this task. And to start working with the chatbot, the user had to click on the blue button. And after completing all of the 5 tasks, the users were asked to complete the SAS questionnaire, consisting of 10 statements regarding usability. Using the Maze platform allowed us to automatically measure the time taken to complete the tasks and gather information on individual clicks based on which the heat maps were created. So now let's move on to the results. In the picture you can see a chatbot's interface with a heat map that shows where did the user click while searching for the question. As you can see, the user clicked many times on many categories, and that shows that our category division may be confusing and needs improvement. The result of effectiveness in 100 is 100% success rate. That shows that every user finished all of the tasks. We also measured numbers of errors per task, and the mean number was 6, which is pretty high, and also shows that we need to improve our tool. The measurement of time taken to finish tasks showed that users found their answers much faster using the main path, which means that it's more efficient, and our script path still needs an improvement. We need to make it more user-friendly. The result of satisfaction is the SAS score obtained from the SAS questionnaires. The obtained score in our research was 80, and comparing it to a scale developed by Bangor et al., our chatbot is acceptable and good, and comparing it to a typical grade rating, it falls within the A range, which is a pretty good result. In summary, the main problems identified during testing was poor category grouping, which led to a longer time it took to finish tasks, and also many attempts to finish them, as it was seen in the heat maps. And it leads to the conclusion that the main path is just easier and faster. To improve our tool, we will regroup the questions and add additional subcategories to better devise certain issues. In the future, we will still develop and improve our chatbot, and our main goals are adding different language options because its availability only in Polish is very limiting, and also adding information on other types of personal protective equipment to our database. As I said at the start of my presentation, the chatbot is still in a development stage, and we will still, and after introducing all of these improvements, we will still gather data from the users, and we'll try to make this as good as possible. Thank you for your attention.
We've got plenty of time for questions. Anybody would like to